Problem 15.115 involves a heavy crate that's being moved a short distance using three identical cylinders as rollers. Knowing that at the instance shown, the crate has a velocity of 200 millimeters per second and an acceleration of 400 millimeters per second squared, both directed to the right. Then once it's determined A part, the angular acceleration of the center cylinder, and the B part, which is acceleration point A on the center cylinder. And it would be the same for all these cylinders, by the way, but we'll consider the center one here. Each of them have a radius, a little r. The point B is the point in cylinder A, the center cylinder anyway, and point in contact with the crate. And the point in contact with the ground is C, and the center I'm going to call G for the center of mass. We're given that 2r is equal to 200 millimeters, so the radius itself is 100 millimeters. The velocity of the crate's 200 millimeters per second. The acceleration of the crate's 400 millimeters per second squared, both in the I direction. So we're going to write out that first of all, if there's no slipping in any at the top and at the bottom, we'll find that V sub B is the same as the velocity of the crate. And since C is the instantaneous center of rotation force, because it is a velocity of 0 with respect to the ground there, then V sub B can be written as omega K crossed into R sub B slash C, which is in the J direction. Anyway, that K cross J gives me negative I, and so I'll have a minus omega times 2R then for this. So if I solve for omega, I'll have omega equal to the velocity of the crate divided by 2r, and with a negative sign, that comes out to be a minus 1 radians per second. Now note that A sub C is the acceleration of point C, which can be broken down into two parts, A sub C xi plus A sub C y. This is in general. But if there's no slipping occurring, then A sub Cx is going to be 0. So we only have an A sub Cy times J unit vector there. So I'm going to write the acceleration of B then as the acceleration of C plus the acceleration of B with respect to C. And the acceleration of B is two parts, ABxi plus AByj. And it has, for C, it's going to have A sub Cri, which is the, this A sub, what we're writing out here is this term again. A sub Bx is A sub Cri plus A sub Byj. Now we're going to write A sub C as A sub Cyj, because we said it was right here. And then you have your alpha crossed R plus omega crossed R. That becomes alpha K crossed into R sub B slash C minus omega squared R sub B slash C. And if you look at the I parts alone, you'll have A sub C crate right there is equal to, and the I part of this is going to be a K crossed into a J. It's going to leave me with a minus alpha times R sub B slash C, which is 2R. So we have a minus alpha 2R, and that gives us alpha then equal to A sub crate, which is 400 millimeters per second squared, divided by 2R, and we have the minus sign carried there. So it's a minus 2 radians per second squared K unit vector. In the B part, we want to note that we can write out the acceleration of G is equal to acceleration of C plus the acceleration of G with respect to C. The acceleration G is only in the I direction because it only moves horizontally. And so it's going to be equal to the acceleration of C, which is only A sub Cy and J. And then you have your alpha crossed R term plus omega crossed R. So when you cross K into J, you're going to get a negative I term out of that. And these other two terms are J terms. So when you equate the I terms, you get A sub G is equal to minus alpha R. And then you also get out of this equation too that A sub Cy is equal to omega squared times R. Now we're going to talk about the acceleration of point A. That's the part we calculate in B here, part B. Acceleration A is acceleration G plus acceleration A with respect to G. So this is A sub G, and acceleration A with respect to G is the alpha crossed R plus omega crossed R term. And so when you do this right here, alpha or K crossed I is going to give you a plus J, so you're going to have an alpha RJ right there. And then you're going to have A sub G, which is minus alpha R, and that's right there. And then you're going to have a minus omega squared R right there. So when you get these combined together, you'll find that the X component of A is 100 millimeters per second squared, and the Y part is a negative 200 millimeters per second squared, or gives you a net of 0.224 meters per second squared at 63.4 degrees below the positive x-axis.